Hi, this is Mr. Mac, and this is the first in probably a series of videos about the normal distribution. Now, the normal distribution is sometimes called the bell curve, and it's used in a lot of situations because there are an awful lot of situations where a bell curve describes how data will behave or occur. Anything where you've got randomness, but there's some force pulling data to some central value, a lot of times you will get what is called the normal curve. Now, the normal curve actually looks something like this. Now, the average of the data will be right along the y-axis. It's the highest point. And notice that as we get farther away from the average on either side, there's less stuff occurring. Now, let's talk about the normal curve for a little bit. Both sides of the curve over here are asymptotic with the x-axis. The area under the curve also from negative infinity to positive infinity is actually equal to 1. Now, this is with the standard normal curve. Now, if we say data is approximately normally distributed, we have some equations that will allow you to transform your normal distribution into the standard normal distribution, and we'll talk about that. Now, it also turns out that the units on the x-axis are in standard deviations, okay? See, for example, 1 unit to the right of the y-axis is 1 standard deviation to the right. 1 unit to the left is 1 standard deviation to the left. And so, ordinarily, the units for the standard normal curve are standard deviations. Because of that, oh, by the way, also, since the area under the normal curve is 1, the part of the area we have in a particular region would be the probability that a data item would fall in that particular region. So a lot of times we find ourselves looking at the area under the standard normal curve, and we just turn it right into a probability. Now, there are a couple of things that you need to know, and the first one about the standard normal curve is what we call the empirical rule. Now, the empirical rule is a rule that tells you how much area there is between plus and minus 1 standard deviation, plus or minus 2 standard deviations, or plus or minus 3 standard deviations. Now, there's a picture here of a normal curve, and I'm going to draw in the empirical rule as I tell it to you. So please watch carefully and try to remember this. Now, first of all, remember, the average of the data will be right in the middle of the curve, okay? A lot of times we call this x bar. X bar is a symbol that means the mean or the average. And sometimes we'll use the small Greek letter mu. So if you see anywhere a question where they're saying x bar or mu, realize that they're telling you the average of the data. Now, if we go 1 standard deviation to the right and 1 standard deviation to the left of the mean, then the area under the curve between those 2 vertical lines is about 68% or 0.68. So plus or minus 1 standard deviation, you will have 68% of the observations fall in that interval. That's the first truth of the empirical formula, or the empirical rule. Now, if we were to go 2 standard deviations to the right and left of the mean, this would be minus 2 standard deviations, this would be plus 2. I didn't put the 1 and negative 1, so let me just do that. Here's plus 1 standard deviation, here's minus 1 standard deviation. Now, if we went plus and minus 2 standard deviations, then this would be the area that would be covered. And the area between plus or minus 2 standard deviations would be 95%. So the area under the curve between those two vertical blue lines is 0.95. Now, if we went 3 standard deviations to each side of the mean, minus 3 to plus 3, the area between those two values is 99.7% or 0.997. 99.7% of the data falls between plus or minus 3 standard deviations. Now, Miss Weaver has put in here a little disclaimer saying, you must know these. Notice the frustration in the larger font and the 2 exclamation points at the end. Now, guys, as a teacher, I can tell you it is very frustrating to know that if the student just remembers something pretty simple, they're going to be able to answer a question on an important test like the EOC. But students go back to the teacher and look at them and said, I had no idea what they were talking about, the empirical rule. I mean, it's something to make a teacher's blood pressure just go through the roof. You've got to know these, okay? The empirical rule, plus or minus 1 standard deviation, 68%. Plus or minus 2 standard deviations, 95%. Plus or minus 3 standard deviations, 99.7%. All right. Now, we've got an example. SAT scores have a distribution that is roughly unimodal and symmetric. You can tell that Miss Weaver teaches AP Stat as well, and are designed to have an overall mean of 500 and a standard deviation of 100. In any one year, the mean and standard deviation may differ from these target values by a small amount, but they are a good overall approximation. What percent of students score above 700? Okay, well, let's take a look at this. What we're told is that we have a normal curve, and in this particular case, the mean is 500, and the standard deviation is 100. So there will be, if I go 100 to the right, that is 600. If I go 200 to the right, that will be 700. Now notice, that's 2 standard deviations to the right. Now, the question is, what percent of the students score above 700? Now, that's this region over here. Now, watch carefully as we reason through this. We know from 300 to 700 is 95% of the data. Now stop and think about that for a minute. How do we know that from 300 to 700 is 95% of the data? Pause if you need to. Okay, we're back. Now, 700 is 2 standard deviations above the mean. 300 is 2 standard deviations below the mean. So between those two numbers is 95% of the data by the empirical rule. Now, the curve has symmetry with respect to the y-axis. So we're going to have the same amount on the left as we have on the right. That means that in, let me get a different color here, in this little region down here and in this region up here, we're going to have a total of 5%, and it's going to be equally distributed, so there's going to be 2.5% there and 2.5% up here. So the answer is the percent of students that score above 700 is 2.5% by the empirical rule. Okay, question B. Between what 2 scores do the middle 95% of all students fall? Well, we already got this because we have the 95% in there. It's from 300 to 700. 95%, again, by the empirical rule, 95% of the students will fall between 300 and 700. C, what percent of students score lower than 400? Now, let's find a different color here. And if I can mark this up without you getting really upset, here's 400. Notice it's one standard deviation below the mean. Okay, now, we know that from 400 to 600 is, let me just drop this down, from here to here is 68%. And again, now that means 32% is outside of that region. And again, the curve is symmetric, so we cut that in half, and that would mean that there's 16% down here and 16% up here. And since we want the percent of students that score lower than 400, that's only this 16%. So again, by the empirical rule, we have 16%. And D, find the percentile for the following scores. Now, the percentile is a statistical term. You probably know what that means, though, because pretty much your parents have gone in to have parent conferences with guidance counselors over the years, and every time you take one of those standardized tests, they tell your parents what percentile you are in, and then they calmly look at you and say, that's the percent of students that scored less well. That's probably not the way to say it. Less well than you did. That's the percent of students that scored lower than you did on the test. That's probably the way they put it. So if we want the percentile of 500, we want the percentage of students that scored below the 500. Now, 500 is here, so below 500 is 50%. 300. Now, 300 is here, and that's the amount below 300 is the same as the amount that's above 700. We've already figured that out. So that's 2.5%. Let's see, what was this, 50% here? 300 was 2.5%. And 800, now 800 is over here at 3 standard deviations above the mean. Now, between 200 and 800, 99.7% of the data falls. That means there is 0.3% or 0.15% on this end and 0.15% on this end. So if we want the percentile of 800, it would be 1 minus let's see, 99.7. This is 0.015, isn't it? It's 0.03%, so 0.015. So it would be 1 minus 0.015, or 99.85% would be below 800. And then 600, let's see, have we done that one already somehow? We know that there's 16% below 400. Oh, there's 16% above 600. So just take 16 away from, 0.16 away from 1, and we get 0.84, or 84%. So 600 would be the 84th percentile. Now I'm going to stop this video at this point, and we'll start another one. And my students are all wanting to say,